welcome back to track 2 and to the session from React to Angular and back, cross-framework testing in Micro Frontends. Shelly and Daniel will guide us through the process of creating an end-to-end and component testing framework for applications built with React and Angular. But before we dive into the session, a few words about Shelly and Daniel. Shelly is passionate about test-driven development in clean code and has over 20 years of experience in software development, in various disciplines like software architecture, development, team management, and process improvements, and many more. The second speaker is Daniel. Daniel has over 20 years of experience and is web development expert and team manager. Besides his daily job, Daniel is organizer of the NG Heroes Meetup and is contributing as a volunteer to the non-profit organization Tech Career in Israel. So let's get Shelly and David on the stage for their session. Hi, Shelly. Hi, Daniel. How are you today?
Hello.
Great.
Are we ready to start?
Wonderful. Thanks. How are you?
I'm fine. Thank you very much. Are you both ready for getting started?
Shelly?
Yeah. Shall we start?
Are you ready?
Yes.
Yeah.
Everybody, please enjoy the session from React to Angular.
So, hello everyone, and welcome to our talk about cross-framework testing, which is basically a talk about Pokemons in disguise of a talk about micro frontends. Daniel, you want to introduce yourself?
Yeah, thanks. So my name is Daniel, and I'm a senior principal at Dell. I'm a developer with more than 25 years. I need to change it from the years to centuries, probably. A full cycle evangelist, dev, test, and rock and roll. Basically, I believe that any engineer should be aware of all aspects of the web development, not only on the expertise. Each one have to be expertise in something specific, but to be aware of everything, DevOps, testing, monitoring, and of course, development. I'm the public speaker and writer, not today, but usually. I'm an open source contributor. I'm volunteer and mentor on Tech Career and Meetup NG Heroes. And today I'm not going to speak at all. I will just stand behind and say, go Shelly, go Shelly. This is my, that's what I'm going to do today. So Shelly, stage is yours.
Thank you. I'm Shelly. I'm also a senior principal software engineer at Dell. I have over 20 years of experience in many disciplines, all related to software development. I'm a code excellence evangelist, and I'm specifically passionate about test-driven development. So what are we going to talk about today? Cross-framework testing in micro frontends environment. Why? To increase test resilience to implementation and functional changes. And how? Using test helper, assertable, and a driver pattern. So we are going to use Cypress in today's demonstration, but the principles we will demonstrate can be used with any testing framework. Basically, we want to achieve decoupling between our test code, production code, and the testing framework. Let's go over two of the pitfalls a development team may encounter in regards of tests. The first one is a minor functionality change. This is a partial list of UI integration test suites of the product my team is developing. Let's take a look at one of those test suites. As you can see, every single test starts with user login. And same goes for all other test suites. Now we get a requirement change to add a mandatory consent to terms and conditions prior to login. The change is one line of code, but now the users have to check the checkbox before they may log in. What do you think is going to happen to all of those tests? Boom, we have dozens of failing tests. Second pitfall is maintenance over time. Let's take a look at this test code and find out what's wrong with this picture. We'll start with the test name. if we see a failing test with this name in a test report, what does it tell us? What wasn't as expected? We'll continue to some code duplication here. If we ever have to change something, we want to change it only once. We want the dry principle. Don't repeat yourself. There's also some control flows. There are also some control flows in the test code, and control flows make it harder to understand the code in a glance. And how can we tell if there are no bugs in this test? The comment here is a code smell. It is a signal, meaning the code is not clear enough. But the most important thing is, what is this test even testing? I read the code several times and I still can't figure it out. Even ChatGPT failed to explain. And what happens if this test starts failing? What if it's a few days before a delivery? Tests don't die, they get skipped. So what happened in this repo eventually is that the test stage was skipped altogether. Now take a look at the list of all those test files on the left and think about all the time and effort that went down the drain. So writing useful and sustainable tests is crucial in order to avoid such pitfalls. But what are the measures of such good tests? We'll start with trustworthiness. We want to run trustworthy tests and accept the results with confidence, meaning if a test breaks or fails, we know something is broken. To be clear, flaky tests are not trustworthy. Trustworthy tests don't have bugs and they test the right thing. Non-maintainable tests can ruin a project schedule, or you risk losing the tests when the project is put on a more aggressive schedule. We will simply stop maintaining and fixing failing tests. Readability means not just being able to read the test, but also figure out the problem if the test seems to be wrong. Now note that without readability, the other two pillars fall pretty quickly. Maintaining tests become harder and you can't trust them anymore. Most importantly, you should treat your test code with the same respect you treat your production code. So we want tests that won't break once you blow on them. Let's see how resilient to change and implementation agnostic good tests can be, even when testing micro frontends developed using different frameworks such as React and Angular. We will demonstrate, using this small example, how we handle those challenges in a large corporate with multiple development teams, each working on their own domain with their own technological stack. So we will demonstrate how micro frontends, which will be referred to as MFEs from now on, implemented using different frameworks, React and Angular, are tested using the same testing infrastructures. When developed correctly, our tests need not be affected by implementation details, allowing us to test the UI in a black box manner. We will be testing a simple application, a Pokemon catalog. We can click on a specific Pokemon to get more information. We can browse through all Pokemons. We can see Pokemon attributes. We can sort or filter Pokemons by type, and we can even jump to a specific Pokemon by its name. So say hello to Pikachu. The application is composed of a shell, note the red header on top, and two micro frontends. The shell is hosting two MFEs, list and details. List MFE, which is listing all Pokemon, is developed using Angular. And Pokemon details MFE, showing more detailed information about a Pokemon, was developed using React. We will be using the Poke API server as our backend. All of our code resides in a single monorepo managed by NX. NX is a powerful open source build system that provides tools and techniques for enhancing developer productivity, optimizing the CI performance, and maintaining code quality. We have libraries implementing components and services. We have 2 MFEs for each, we have application for each MFE, and we have a shell application. And this is the dependency graph in our repo. The shell depends on both MFEs. The details MFE depends on the Pokemon details library, and the list MFE depends on the Pokemon list library. And what about tests? The application's end-to-end tests depend on the application, of course, and on the MFE's end-to-end tests. And we also have a test helpers library, which contains builders to generate random test data to be used by all tests. Let's run some tests. We'll start with end-to-end tests. Front-end end-to-end tests refer to a helper robot that behaves like a user to click around the application and verify that it functions correctly. So we will start with the end-to-end tests of the Pokemon application, shell and MFEs. What are we testing? That the first 10 Pokemons are displayed by default, that the correct Pokemon details are displayed when clicking on more info, and that the next Pokemon details are displayed when next is clicked. We'll continue with the end-to-end test of the details MFE. So we lost the red header on top. What are we testing? That the correct Pokemon details are displayed, and that the first Pokemon, which is Bulbasaur, should be displayed if the Pokemon name was not found. And moving on to the end-to-end tests of the list MFE, what are we testing? Pokemon should be filtered by type, and first 10 Pokemons should be displayed by default. Let's take a look at the test code. Before each test, we navigate to the home page. We then test that 10 first Pokemons are displayed by default, that searching a Pokemon by name leads to the correct Pokemon details, that searching for an unknown Pokemon will lead to displaying details of the first Pokemon. And if you're wondering where are all of those methods coming from, good, stay tuned. It will be all clear soon enough. Now let's dive into this test case. Before each test, we click on more info, and then we see the Pokemon details. We test that when clicking on back, we navigate back to the Pokemon's list page, and then we test that the correct Pokemon details, such as name, types, are displayed, and that when clicking on next, the next Pokemon is displayed. Things to note here: each test tests one thing and tests it well. There are no control flows in the test, and if a test fails, just looking at the test name in the test report can tell us what went wrong. Okay, we will now move on to the separate Micro Frontends end-to-end tests. Let's start with the details MFE. Before each test, we navigate to the home page, which is the details page. We will then test that the correct name is displayed, the correct abilities, and the correct number of types. And as for the list MFE end-to-end tests, before each test, we navigate to the home page, which is the list MFE page. We then test that first 10 Pokemons should be displayed by default, and that the correct number of Pokemons are displayed when filtered by type. Let's move on to integration tests. Front-end integration tests refer to running the front-end application while mocking the server responses, so no backend. Let's run the details micro front-end integration tests. What are we testing? That an outgoing request with the correct Pokemon name is being fired, that the correct details are displayed. Note as this is an integration test, we're using randomly generated test data and not the actual data from the backend. So there is no Pokemon called Oilpick. And let's run the list MFE integration tests. What are we testing? That an outgoing request with the correct Pokemon type is being fired when we're filtering by type, and that the correct Pokemons are displayed. Same here, as this is an integration test, we're using randomly generated test data and not the actual data from the backend. Let's take a look at the code. This is the list MFE integration test implementation. So we are generating random data in order to test the list MFE with no backend. Before each test, we set the preconditions, intercepting outgoing HTTP requests and setting the responses with the test data we just generated. Only then we navigate to the homepage, and we then test that an outgoing HTTP request with the correct type is fired and that Pokemons are displayed according to the mock response we created. Mocking the backend server responses, which we will not be doing during an end-to-end test, enable us to test edge cases, simulate errors, and test our application without the need of a fully functional backend server. And same goes for the details MFE integration tests. Before each test, we set the preconditions using test data. We then test that the correct Pokemon information is displayed. Things to note here, the test code is phrased as an acceptance criteria, given precondition, when something takes place, then expect some actual result, should expected result. And now to the Holy Grail unit tests. But when we're testing a UI component in isolation, it is referred to a component test. Referred to as a component test. We will mount the component detached from the rest of the UI while mocking dependencies such as services. Spies and stubs and mocks are known as test doubles. Similar to how stunt doubles do the dangerous works in movies, we use test doubles to replace troublemakers and make tests easier to write. Stubs are used as replacements for actual methods and can be manipulated to return the values we want them to return during the test. Spies spy on functions and can later be interrogated to verify that methods that should have been called during the test were actually called. So we are mounting the Pokemon list component and testing its behavior while mocking services and other dependencies. But the Pokemon list component is composed from subcomponents, which are also covered by component tests. So as you can see, we're testing each component in isolation while mocking the rest of the application. And same goes for Pokemon details component tests, including subcomponents. Each component is mounted in isolation and tested separately. So let's take a look at the components test code. Let's start with the details component. We are generating random data, random test data, and setting the preconditions. Before each test, we mount the component, and then we test the component in isolation using spies to verify events are emitted correctly. And same goes with Pokemon list component. But as it is implemented using Angular, we need to prepare a test bed and add the required providers. This is how we inject the mocked services. We're using Angular's built-in dependency injection. And we then set the preconditions before each test, and then we test the component in isolation using, again, mock services to set the test data and verify and spies to verify that events are emitted correctly. So this seamless way of testing components, micro frontend and application, is based on using helpers, assertable, and driver, test drivers. Test code uses the test driver so that the test code is unaware of the implementation details of the component, of our production code. The test driver uses test helper, so it is unaware of the testing framework. Let's focus on test helper, test driver, and assertable. Test helpers are designed to decouple our tests from our testing framework. Theoretically, if we wish to switch our testing framework, all we have to do is implement a helper for the new testing framework, and all of our tests will work again. Test helpers expose 3 public properties: given, when, and get, wrapping most useful commands so our tests are as decoupled as possible from our testing framework. The given property holds methods which allow us to set preconditions before something takes place, like intercepting HTTP responses and creating stubs. The when property holds methods of events which will take place during a test, like click, drag and drop, hover, etc. The get property holds methods which will give our tests access to the output in a black box fashion, such as getting the color of a text element rendered in the browser. Helpers also steer us in the right direction in terms of test readability, forcing us to use the given, when, get terms in our test. In this demo, we're using Cypress Helper, which is an open source class designed to be used in any test level and holds common methods used in Cypress tests. We are also using Cypress component helpers, which are designed to be used in component tests and are not framework agnostic, as they have to mount the component. What does a helper look like? Let's take a look at the open source Cypress helper we are using in our test. Let's focus on those 2 methods, for example, check and uncheck of a checkbox. The implementation is very simple. We are selecting the element and then using check or uncheck from Cypress. So we are simply wrapping Cypress methods. The assertable class wraps a subject we wish to assert something about. For example, we wish to assert that an element is disabled. Assertable wraps Cypress chainable so that our tests are as decoupled as possible from Cypress. By using the assertable class, we can use the same assertions in our tests regardless of the testing framework we use. If we wish to replace Cypress with another testing framework, all we need to do is to replace the implementation of the assertable class, and we can keep all our tests. The cool thing about assertable is that you can also add assertions of your own by extending the assertable class. Here is an example of adding an assertion that asserts the subject is included in a style stored in the local storage. So you can add your own specific assertions according to your application need. Test driver pattern is based on the page object model from Selenium. The driver pattern basically means that we have an additional class which is responsible for bridging the gap between our test code, or our test file, and our component. It will help our tests be unaware of the inner works of the component. In addition, if we change something in the component which causes the test to fail, we will just have to amend the driver and our tests will pass again, given the same logic applies. If you remember the first pitfall we went over at the beginning, all we have to do is change the login method in the driver and all the tests will become green again. Every driver exposes 3 public properties: given, when, and get. The given property will hold methods which will allow us to set preconditions before something takes place. This is a classic place to have methods which will set the inputs which are going to be passed down to the component. The when property will hold methods of events which will take place like render, click, etc. The get property will hold methods which will give our test access to the output of the component in a black box fashion. Let's see an example. The Pokemon image component displays an image. Unless there is an error, then it shows a fallback image. Note the data test ID attributes, which will allow us to select those elements in the DOM during the tests. What test should we compose for such a component? We'll have one test asserting that the Pokemon image is displayed given there is no error. So, given an image source, given a mock image response, when we render the component, then the image source should be equal to the input source. And we'll have a test asserting the fallback image is displayed given that the image is not found. So, given an image source, but given the image is missing, we return a 404 error code. When rendering the component, then the fallback image should be displayed. Things to note here is that we are using the drivers given when and get properties. There are no control flows in the test code. The test is readable and maintainable, and the test name indicates what went wrong in case the test fails. Note that even someone who is not a developer but is familiar with the product can understand what is going on in this test code. And this is what it looks like in action. We have one test showing the image from the test picture and another showing the fallback image. So time to discover what does this test driver look like. So this is a test driver. It has 3 sections. In the given sections, we have methods to set the source of the image and methods to intercept and mock the response of the image request. In the when section, we have a method to mount the component. And in the get section, we have methods to explore the DOM and the outcome. Note how the driver uses helper functions to implement the methods required to drive the test. So theoretically, if we switch to another testing framework, the change will be relatively easy, as we will implement a helper for the new testing framework, keeping the driver very similar to its current implementation. Okay, and now the gimmick. Test drivers can be composed to drive the test of a component composed of multiple subcomponents. This way, test drivers can be used as building blocks to compose more elaborated test drivers. So in our example, the Pokemon details driver will hold a Pokemon image driver and expose its methods. We do not wish to repeat ourselves. We do not want to implement again the methods we already implemented in the Pokemon image driver. And we can eventually create a driver for an entire page in our application, made of many components. Let's look at the code. As you can see, the Pokemon details driver exposes the methods of the Pokemon image driver. We have already implemented a method to get the image source of the Pokemon image, and we do not wish to repeat ourselves. This way, if there is a change, we only have to make it in one place. Remember the login example? And the same goes for the Pokemon attributes subcomponent driver. The Pokemon details driver exposes the Pokemon attributes driver's methods. And an integration driver will be composed from all relevant component drivers. In our case, the Pokemon details component driver, and will contain integration test related methods in addition. For example, methods for navigation. Note how most of the driver methods were already implemented in the component driver. And as shown before, these are the integration tests of the details MFE. Note how we are accessing the method from the subcomponents drivers in the test. And this is the driver for the entire Pokemon application, shell and both MFEs, exposing the end-to-end drivers of each micro-frontend, regardless of whether the MFE is implemented using React or Angular. So we are using test drivers as building blocks to create more elaborated test drivers using driver composition, so that eventually we have an application driver to drive more elaborated test flows on the entire application. And as shown before, these are the end-to-end tests. We are accessing the list and the details MFE test drivers. So now everything is fine, everyone is happy, but then a QA finds out that sometimes when clicking on next, the application goes crazy. So somebody discovers a defect. When we find a defect, the first thing we'll do is write a test that fails due to this defect. Note how easy it is to add such a test now that we have all the drivers in place. Let's write it together. So when we're navigating to the home page and when we're clicking on more info, we are now spying on outgoing Pokemon requests. When we're clicking on next, the number of requests fired should be 1. Now, when we have a failing test ready, we can fix the bug, knowing in confidence it is actually fixed once we fix it. So let's circle back to the beginning of this talk. If you recall, we had dozens of failing tests due to a change of one line of the source code. And of course, the fix is also one line of code. All we have to do is add the check consent in the login method in the integration driver, and all the tests are green again. Some things to pay attention to. Test drivers should be exposed from a separate endpoint. Otherwise, we will have an unwanted mix of test code and production code. You will have to import the Angular compiler in your end-to-end tests if you're using Angular component drivers. We recommend using chance and the builder pattern for better test coverage. And we recommend using a lazy stubber like TS Stubber. And let me say a word about it. TS Stubber is an open source, lightweight, lazy stubber, meaning methods are stubbed only when called, saving the need to create stubs for every method of the class we're mocking. TS Stubber is generic, so you can choose the mocking framework you wish to use. For example, Jest or Sign-On. In addition, mocked classes constructor is not called, so there are no side effects during the test. To summarize, sustainable and useful tests are trustworthy, maintainable, and readable. The driver pattern enables decoupling of test codes and the production code, so that our tests can be unaware of the implementation details and focus on output. And as you have seen, our tests can be literally framework agnostic. Using test drivers and helpers improves test readability and maintainability. And if there is one image to remember from all this talk, it's this image. The test code uses the test driver, so that the test code is unaware of the implementation details and assertable to achieve decoupling from the testing framework. The test driver uses the test helper so that it is unaware of the testing framework. So now say you wish to adopt these patterns into your code base, which already has countless tests implemented. How do you start? You start off simple. Whenever you introduce a change, build a driver for the component you change. It does not have to be perfect or complete. Just add the methods you need for the test you're adding. And adding one driver at a time, one test at a time, will get you there. Slowly, but surely. We started implementing these testability infrastructures in our components libraries at Dell about 18 months ago. At first, there wasn't much, but after a few months, most appliances are adopting those infrastructures, and they keep coming back and asking for more drivers. So it may take some time to get used to using test helpers and assertable and test drivers, but the best way to have an easy adoption is to engage in some hands-on practice. So given this is of interest to you, when this session is over, then you can find more information here. You're welcome to scan the QR code now, and you can find here the link to the repo, documentation, and many other resources. Thank you. We can answer some questions now, if there are any.
Yeah, there was a question if there is a Pokemon app and test available in a public Git repo. So if anyone interested to see the public Git repo and articles of Shelly and also the Mocker, right, library and many other cool things, scan this QR code. Would you rather end-to-end test each micro frontend individually, even if it means providing a mini shell for this micro frontend, or when all micro frontends were integrated in the shell? We have a heated discussion about this topic. Okay, I will answer this for you. Okay, so the idea is, the whole idea of the micro frontends is to make teams, okay, run independently. And we have in our use case, we have created the ability to execute full, and basically what Shelly showed today is also the ability to test, end-to-end test the flows inside of the each of one of the micro frontends separately. Okay, there is going to be definitely tests that will, you know, the long flows. I'm doing something on one micro frontend, and then I'm going to another one, and I'm checking that it exists there, etc., etc., etc. There's this kind of, you know, the integration, global, real end-to-end tests that happens, I don't know, in night builds or something like this. But if you're making some kind of small changes on your micro frontend, your team made small changes on your micro frontend, so there's no reason to test everything, okay, the entire application with all micro frontends in it and the builds, etc. So yes, there is, it's possibility. It's good to do. It's good to be at least on the merge request. Depends on the branching strategy you're working with, but it's good to have it on the merge requests per changes, not the entire application, but actually what was affected. And by the way, in X monorepo is have a lot of good functionality around this area to detect what was affected and execute only the micro frontends that was affected. Also, we have, for example, some kind of shared library or something like this. If this was affected somehow with your changes, also can be tested separately, regardless to the micro frontends, etc. So yeah, it requires a little bit of investment, a little bit, not much investment, one time into the flows, into the pipeline CI/CD, and then trust me, you will enjoy it, okay? And it will keep your application safe and tested.
Okay, thank you for covering the first question. So you started already with answering the questions. Then basically we have another one, which is sometimes feedback on runtime and tests of Angular is kind of cryptic. Do you have any tips or insights on this?
You just have to tough it out.
Yeah.
Angular is improving, but I understand what you're saying. Just a lot of Googling. Yeah, sorry.
Google it.
Yeah.
Okay. You have anything else? Any other questions?
Do we have any other questions? Are currently not in the comments yet. So, is there any?
Yeah, I see here from live. Doesn't start.
It says we're adhering to the share nothing principle, where each MFE, is indeed independent of other MFEs except for auth and the UI lib. If they have to, message bus is the way of communication. Actually, we are working on an API first approach, and we have a shared repo for all APIs. And I'm not sure I'm answering the question, but many of the data models are derived from the single API repo. Is that what he meant, or?
It's difficult to say. I will just add, if the approach that we work and the approach that I believe is that the shared data is very small, okay? And basically it's very simple to share, I don't know, token, like access token, for example, or something like this. And that's it. All MFTs, each one of the micro frontends, it's fully independent and decoupled. They all sit on the same code base, they all sit in the same mono repo, okay, for the easier management and for the easier dependency management. But in terms of the data and state management, each one is responsible for its own. The only one thing that is shared is actually like access token and stuff like this. User data probably that don't need to reload each time for each one of the microfrontends. It can be shared via the local storage cookies or whatever it is. And it's absolutely have not, it's okay. It's very, very easy to mock this data and very easy to implement it on the testing too. So it's not something difficult on our side. Okay, we don't have a lot of data on the UI, and if we do have it, so this data and the state is only for the specific view only. Okay. Oh, we have here Jonathan Arad who said great lecture. Thanks, Jonathan.
Okay, good. So at the moment we do not have any further questions. So you answered the question already whether the we have also earlier whether the code is available in the public repo with the QR code. Can download. So maybe we give a few seconds to scan the code again, and maybe also in the meantime some further question comes up.
I will put the link to this also inside of the comments on the chat on YouTube too. Okay, so it will be everyone will see it.
Okay, good. Then thank you very much, Shelly. Thank you very much, Daniel, for your interesting presentation and diving into the testing aspect, which is.
I have prepared this. The whole lecture was sitting doing this. Oh, Shelly. That's what I came here to do, right? So.
Good.